Today we are going to do a little review. So these are topics that we've done in the past. The reason we're doing that is because we're coming up to our first benchmark. And so these are some big concepts that we need to make sure we understand. First set of directions is going to ask us to verify a point is on a line. They're not going to use the same words there. They're going to say, without graphing, tell whether each point is on the graph, and then they'll give you an equation. Here I've got different equations, different points, but it's done the same way. So let's take a look at the first problem. Here we have an equation, and we have a 2x plus 5y equals 16. They give us this point, and we want to see, is this point on this line? Well, to verify, to prove that it is, we're going to use substitution. We're going to take our x value, which is the first number, 3, and we're going to put that in place of x. We're going to take the 2, which is our second number, our y value, and put that in place of y. Do some work and see if it equals 16 or not. So we'll go ahead and do that work. We've got 2 times by the x value, 3. And then we add 5 multiplied by the y value, 2. And then this should equal 16. So again, the terms I substituted were the numbers in the ordered pair. The ones I just highlighted here. The 3 went in for x, the 2 went in for y. So I go ahead and do some work and see if it ends up equaling or not. So 2 times 3 gives me 6, and then 5 times 2 gives me 10. And if that point is on a line, those two numbers will add to make 16. And sure enough, they do. So when they do add to make 16, those are equal numbers, then we say yes, that point is on the line. And that's what we're asked to do, to define, actually really see whether it's on the line. So there it is. Yes, the point is on the line. Well, let's take a look at the next one. We've got, this time, a fraction as a coefficient, fractions as points. So when we substitute these x and y values, we're going to have to make sure that we're really careful when looking for cross-canceling. So we'll start with our negative 5/3. That's our x value. Again, that's going to go in for x right there. The 2/3 we're going to put in for y. We'll see if it ends up equaling or not. So again, we're going to take the same equation, 6, but in place of x, we're going to put that value of negative 5/3. And then we're going to bring down that plus sign and the 1/2, and we're going to, in place of y, put the number y is in the ordered pair, which is 2/3. And then if that's the case, if those two numbers multiply and then add together to equal negative 10/3, then we get to say yes, that point is on the line again. So we go ahead and do the work here. Again, we are looking for cross-canceling first. Here we have negative 5/3 times 6/1. That 3 goes into the 6 2 times. So I multiply these two numbers here, the 2 and the negative 5, that gives me negative 10. We're getting close. Let's see if this number makes a negative 1/3. Here the 2's cancel out, and I have a plus 1/3. Oh, it's not going to make it, because here they're opposite in sign, not the same sign. If this were a negative 1/3, if this was a negative 2/3, then we would add the two numbers, but they're not. They're opposite in sign, so we need to subtract. So if we take 1/3 from 10, we're left with 9 and 2/3. That is negative, which isn't quite the same as negative 10 and 1/3. So those are not, that point is not on the line, so we would say no. Well, the next set of directions you see will ask you to find x and y intercepts. So we have to remember something about x and y intercepts. And the key was that we talked about for the x-intercept was that we wanted to set y equal to what number? 0. That's right, 0. So we're going to set, for the y-intercept though, we're going to end up setting x equal to 0. So the x-intercept is is where the line crosses the x-axis. And if we're on the x-axis, if you look at a coordinate plane here, and we're on the x-axis, that means we don't go up, we don't go down. We are right on the x-axis. For the y-intercept, here's a y-axis. For y-intercept, we are right on the y-axis. We don't go left, we don't go right. We are just right on the y-axis. That's why we set x equal to 0. So we go ahead and do that. So for the x-axis, our x-intercept, we're setting y equal to 0. This term just cancels right out. And then we rewrite what we've got there. And so that negative 2y is gone. And all we're left with is this 1/2 x equals 8. Over on the other side, now this y term is all what's left, because we're going to just cross that 1/2 x right out. And when we do that, what we're left with is a negative 2y equals 8. And then we go ahead and solve. And so we just do opposite operations here. So unlike on this side, we multiply by the reciprocal. So I'm going to multiply by 2 over 1. And do the same thing on the other side, multiply by 2, which is the same thing as 2 over 1. On this side, I'm going to divide by negative 2. So let's see what's left over. Here I've got my x value, x equals 16. And so I can write that as an ordered pair as 16, 0. And then over here, divide by negative 2, I've got y equals negative 4. And so I write that as an ordered pair as 0, negative 4. So that's it. Those are my two intercepts. Just taking a look at a couple other problems. These are tougher ones here because we have to do an extra step. In order to find the intercepts, we want x and y to be on the same side. So if x and y are not on the same side, we need to get them on the same side. So I'm going to move that 2x back over to the right-hand side. So what I've got left is this, 8 equals, and then I've got a negative 2x and a positive 8, or positive y. So to find the x-intercept, remember I'm going to set y equal to 0. I'm going to cancel out the y term, so all I'm left with is 8 equals negative 2x. For the y-intercept, I'm going to set x equal to 0, so I've got my answer, 8 equals y. So I've just got one step here to do, and that final step is to cancel out or move this negative 2, divide by it. So I divide by that negative 2, and we've got our answer here. So negative 4 is what x equals. Y equals 8. So we can write the answer as an ordered pair. Negative 4, 0, and over here we have 0, 8. Well, one more problem to do, and we have the same situation. That's why I wrote this one out, to give you another example of this type. For x and y intercepts, always get x and y on the same side. That way you won't make any sign errors. So we go ahead and add it. We want to isolate that constant. We added that 2x to both sides. So I'm left with a 4y plus 2x equals 16. So we go ahead and find that x-intercept, and we'll also find this y-intercept. And so the x-intercept, we're going to cancel out that y term. This will be gone. So all we're left with is 2x equals 16. For the y-intercept, remember, you're on the y-axis. That means you're not going left, you're not going right, you're staying right on there. So x is 0. So you're canceling out the x term. So all we're left with is 4y. And so we go ahead and do that work. We do some multiplying. Well, we have multiplying by a variable, so we're going to do the opposite of that. We're going to divide by 2. And this side we'll divide by 4. And we'll have our two values of x and y, the two intercepts where it crosses the x-axis and the y-axis. So here x is 8, over here y is 4. So we've got it. When y is 0, x is 8. When x is 0, y is 4. And those are the intercepts. So the next part, we'll be talking about graphing lines using x, y intercepts, and also using slope and intercept form.